So they said, guys, rule number 3, they said, simply is a farmer, she has a square field with sides of 45 meters. So they're telling you the shape of the field, right? It's a square, that's important, because if it's a square, we're going to need to use the area formula for a square. Okay, so you have to take note of the shape of that field, all right? Then they say she plants 8 maize plants in every square meter. How many maize plants does she plant? Now, guys, if she plants 8 in each square meter, you have to figure out how many square meters she has, right? And then times that by 8. So how do you figure out how many square meters she has? You need to find the area, right? Side square. Square meters is the area of that field, guys. So it was a square field, all right? They told you that the size of that field was 45 meters. So you're going to do 45 squared, right? Good on the calculator, that's fine. 2025 square meters. So guys, can you imagine 2025 little blocks, okay, of squares? That's the field. Now there are 8 plants on each of those little blocks. So how many plants are they going to be? 2025 blocks times 8 on each block, right? So you have to times. Many of you are dividing. Okay, you have to times. Because in each block there are 8 of them. So it makes sense if you times it, right? Every single block will give you 8 plants. So there were actually 16,200 plants. That's a lot. All right. Number 6. We did speak about this one in class. Now, guys, some of you might have wanted to put in an extra line. So I'm actually going to add that extra line quickly, just to show you what I mean by that. I know when we did the example in class, that one on the board, right? Which is gone now, but of the different triangles, we wrote area of triangle this, plus area of triangle this, plus area of triangle this. So if you wanted to, guys, you could have said that the area of this whole shape is the area of the rectangle. You don't have to put this step in, but just if it makes it easier, plus the area of the triangle. We don't have names for these shapes now because they didn't give us letters on the picture, right? But maybe if we had like an A and a B and a C, you could have said area of triangle ABC, but it's fine. All right, so if you want to put that step, and I think many of you are confused. Many of you are asking me, ma'am, what must you write first? Okay, you can write in words. Area of the rectangle plus the area of the triangle. That's perfectly fine. Then remember, the area of the rectangle is length times breadth. Okay, that's the formula. Length times breadth. So you need to figure out of this rectangle what's the length. Now we did look at this together, but just to remind you, the whole arrow is 17 centimeters long. The triangle is 5 centimeters. So the length of the actual rectangle is going to be 17 minus 5. Right? It's going to be 12, yeah? Yeah, it's just it might give you issues with rounding later on, and it takes much longer. So guys, I really want you to try to lay it out like this. I don't know why so many of you also against doing it all in one step. It's going to take you time. Remember, when you're doing things in exams, often you don't finish because there isn't enough time. So this is a way to do it faster. Okay, so the area of a rectangle is 12 times 3, yes? I don't know why it's 3, then again, 12 times 3. And then the area of a triangle, remember, it's half base times perpendicular height. You have to know those area formulas all by heart, right? The base we said is 11, and the perpendicular height is the actual height of the triangle, which is 5. So half times 11 times 5. Okay, so the answer there, guys, is type that into the calculator. Do you know how to do that all at once? Have you used the bracket buttons on the calculator? Let me show you. Bracket, right? 12 times 3, close bracket, plus another bracket. How nice is that? You can type a half, or you can just do 0.5. Right? I think we all know that 0.5 is a half times 11 times 5 equals 5. Yeah. 127 over 2, so you press 8D, and then you have your answer. Okay, if you weren't sure how to type that into the calculator, you don't have to type it in as two separate calculations and then add it together. You can do it all at once. Yeah, you will be able to use the some of it, yeah, but maybe not all of it. It might be like a 20-minute section and add that in. I don't know, but it hasn't been taken, so I'm just, yeah, we'll see. Maybe you'll be able to use the whole thing. Okay, fine with this one, right? Any questions on number 6? Will you be able to do a question like this in a case, hey? This one. Now, guys, the thing with this is you get like half marks, right? So if you'll probably get a mark for this 12 times 3 and a mark for that, and then a mark for the final answer. Okay, so a question like that, if you work 3 marks, maybe they'll even give you an extra mark for knowing that you must add the two together, but I think that's a bit obvious, right? That is the 2 parts added together, but maybe. So if you forget how to find the area of a triangle, at least find the area of the rectangle, you can get 1 mark for that. Okay, I really don't want you guys leaving questions out. You must calculate the parts that you can, right? Because more often than not, you'll get marks for that. Okay, next. Exercise 16.2. They ask you to find the areas now. So I'm going to 16.2 on page 190. Remember, you guys calculated the circumference of this question the previous day. All right, so you didn't do circumference again. Just have to find the area. So for 1A, they told you that the radius was 83. And your area formula that you have to know all by heart, very important, pi times radius squared. Oh, I didn't actually show this calculation. Sorry, let me add a step here. So you would say pi times this 83. You can put in brackets, but you'll put up when you have to. And that is what you'll type into the calculator. And then just round that value. Okay, so I'm just going to show you quickly. Shift the pi button there at the bottom times 83, and then the x squared button, right? That squared the whole thing. Equals, it will give you an answer in terms of pi, so then you press SD, and that is what you're going to write. Okay, 21,642, 43. And remember, please guys, if your unit that was given was in centimeters, your answer for area has to be centimeters squared. They take a mark off if your unit is not correct. So if you wrote just centimeters there, -1. If you didn't write anything, right? If you just had the value, also -1. Okay, so please make sure, maybe highlight that unit there. I want you guys to do the mark on something like that. Okay. If you did write and highlight the thing, please add it in. Any questions on 1A? Right, 1B, the diameter, 257 millimeters. But now remember guys, area, the formula works with radius squared. So you can't put the diameter value there and square it, right? You have to have the radius. So first you need to calculate the radius. Remember that your radius is always half of the diameter. Okay, so that is what I did there. Radius is always your diameter divided by 2. Over 2 or divided by 2, it's up to you. It's the same thing. You have to calculate that first, right? You can also calculate it in the actual formula. I'll show you now. But basically, you can't use the diameter value as the radius. Okay, they're two different things. So first, you take that diameter value divided by 2, and then you use it in that area. Now the unit that they gave us was millimeters. So the answer has to be millimeters squared. Very important. Are there any questions on that one, guys? No questions? Who got both of those correct? Okay, very few. Guys, what went wrong? Let me know. What's the problem? Okay, what did you guys do wrong? Don't need to feel shy. We can all learn from each other's mistakes. Okay? Okay? You don't know. Okay. Did you use the right formula? Okay. Yeah, that's important, right? It has to be pi radius squared. Okay, good. So now you're not going to make that mistake again, right? What else, guys? What else is wrong? There's so many that we need to pay hands on. And it's not very wrong. The graph is good. Okay? So well? Well, the other one. Okay, so it was maybe just your rounding. Okay. Okay, that's not the end of the world. Please thank you. Oh, wait, sorry. For A, if I go for it's the same. Also, just your answer. Yeah, what is 83 times 83? And I'm not from that. No, it's 6889. And then that's what you multiply by 5. Okay, got that. Right. I think it's got the minute. Okay, so must have put in the wrong thing. You know? Okay. So circumference in the area. Okay. Remember, guys, I said the other day the nicest or the easiest way to remember which formula for the circle is the area formula of the one that has a square. Okay, so whenever they ask you for area, you must always think square. Okay. All right, thank you guys for explaining there what went wrong. It is good to reflect on our mistakes, right? So that we don't make the same mistakes again. I'm just quickly busy drawing this next picture. So that we can look at it on here. So I don't have to put the book on the board. The next picture was quite tough. Or the next question rather, which was number 3, right? They said, sorry, it's not the best picture there, I tried my best. They said that we have this piece of wood, was it? A square piece of wood, rock, right? And then they said that this length of the actual piece of wood was 1,800 millimeters. And since it is a square piece of wood, the length of all the sides would be the same, right? 1,800 millimeters. But he wants to cut this piece out. This is what he wants. The circular part. Right? He wants that. That is going to be the table part. But this is the piece of wood that he has. So guys, what you needed to understand here is that if the length of this side is 1,800, it's also going to be 1,800 here. Right? That length, sorry, it's a bit skewed. Let me just fix that. That length is also going to be 1,800. Guys, if you think of a square, right? The lines go up straight. They don't like dip in or go around, right? Then it's not a square. So everywhere on this piece of wood, the length between that side and that side is going to be 1,800 millimeters. So the diameter of the circle, right, the circular piece of wood that you can cut from the square is 1,800. That was the length that you had to make on this question. Sorry. So the diameter of the circle was 1,800 millimeters. I'm not sure if all of you were able to see that. Lots of people asking questions in class talk. You know, it's able to help you. But does that make sense, guys? Everywhere on this piece of wood, there it's going to be 1,800. There it's going to be 1,800 everywhere, including in your diameter, right? Right through the middle of your circle. So that's also going to be 1,800. So what's the radius of the circle then, right? The diameter is 1,800, the radius is going to be 900. Right? 1,800 divided by 2. Okay? So what were they asking us? They were asking us for the area of the largest circular tabletop that you can cut from the wood. I think maybe also the wording there, the fact that they said the largest tabletop might have been a bit confusing. But guys, basically, because I mean, you can cut a circle like this as well, right? Using the same piece of wood. But would that be the biggest tabletop that he can get? No. No. The biggest one that he can get is if he's just cutting off those like corner bits, right? So that the diameter of the tabletop is also going to be 1,800. Okay, so you're just going to cut off those little corner parts there. So the area, what's the area again? What's the formula? Area is pi times radius squared. So that is going to be equal to pi times 900 squared. Or you can put it in brackets like I did before. Then you take your calculator, you work that out, and you will get, this is a big answer because it's in millimeters, right? Which is a bit odd. We don't normally work with such big millimeter values, but we do need to give the answer in this form. So it was 2, 5, oh dear, you know what? You know what? They said we must give our answers in meters squared. So what's the easiest way then to do that? Convert that radius to meters rather. Okay, instead of finding a very big answer and then converting that onto meters. Sorry, I didn't read that. That was the very last sentence. They want the answer in meters squared. So guys, how many meters, oh sorry, how many millimeters are there in a meter? Is it 1,000? 10,000. No, not kilometers. How many, let's go in smaller increments. How many millimeters are there in a centimeter? 10. And then how many centimeters in a meter? 100. 100. Alright, in 1,000. If I never think we're wrong, right? I was just explaining it a bit more. So guys, one centimeter is 10 millimeters. That's the easiest one to remember. Right? That's also the only one that's just 10. So then 1 meter is actually 100 centimeters. So to go from millimeters to meters, you have to times it by 1,000. Right? So there are actually 1,000. Where am I going to write this now? Sorry, let me just move this up a bit. I think there is a summary of all those conversions somewhere, which I'll print for you guys. I'll just make a note so that you have them in your books. So 1 meter is 1,000 millimeters. So our radius is 900 millimeters. So what's that going to be in meters? What do you guys think? 900 millimeters in meters? 0.9. Okay, so let's add here, right? I'm going to change that as well. Let's add to this line, 900 millimeters is actually 0.9. 1 meter would be 1,000. Okay, so it's just short of 1,000 millimeters when you have 900. So 0.9. And if you want to, you could actually have done this here because this would make it a bit easier. 1,800 millimeters, how many meters is that? 1.8, right? And then that's maybe even easier now. You're just going to divide 1.8 by 2. Okay. Sorry, I didn't notice that when I read the question. So this, my apologies guys, you'll have to change this quickly, is actually going to be 0.9 squared. So not 900 squared like I had it at first. So our final answer is then much more realistic, 2.54 meters squared. Okay, it does make more sense to work with meters if you having this kind of project. Alright. So number 3 was actually very complicated, guys. Not only did you have to figure out this whole picture that they gave you, but you also had to do a conversion. We actually haven't practiced yet. Any questions on that one? Okay, number 4 was an interesting question that I've seen in many tests and exams before. You have a post, right? And then you have a goat that is tied to this post by a rope, all right? So that is the rope. And here you have a goat. I'm not going to try a draw one, right? You can draw one if you want. Then they say the rope measures 6 meters. That's the length of the rope. Calculate the area of grass that the goat can reach to the nearest meter square. Now guys, if this the rope is stretched out, right? It's 6 meters. Do we agree that we can eat all around that? Sorry, that's very, oh, that's the worst circle I've ever done in my life. We can eat all around like that, okay? That is supposed to be in the center, so it's a bit off. Let's see if I can just move it slightly. Do that, and then move it. Center a little bit. So not quite in the center, but it's meant to be. You guys understand that the rope can go 6 meters all around that post, right? So the post is going to be like the center of the circle, and the area that the goat can eat, right? The area of grass that he can reach is going to be the area of this circle, all around that little post. With the radius of, what's the radius of the circle? 6 meters. Okay, so they're actually asking us to calculate the area of the circle. So I'm going to write here on the side, area of grass that goat can reach is actually going to be the area of circle with a radius of 6 meters. Obviously, in a test or exam, you wouldn't have to write that whole thing up. Okay, it's just a little explanation of what you have to calculate here. So again, because it's the area of a circle, we know that it's pi radius squared. So we're going to say pi times 6 squared. And then we'll just work out what that is. That is 113, comma 1, because it's 0.97. And this is meters squared. Oh, sorry. I must read my instructions. They said to the nearest meter squared, so it's 130. Okay, was that? So this to the nearest whole number, do we agree that that's just 113, right? Because this would become a 1 if we rounded that up, but because it's a 1, it's smaller than 5, so we would have to round down. Okay, so that's why it's 130. Any questions? Okay, what else do we have to do? It was 16.3, number 1. Yes? All right, guys, the next one. Let me just see. Sorry, I just wanted to see how much space I had left. All right, 1A. I'm not going to do this now. Okay. 1A, that is the picture that we're looking at. They want us to find the area of the shape. Now, I mean, the shape doesn't even have a name, right? It's like a funny shape. It's a shape basically made up of other shapes. So we call those composite shapes. Do you guys notice that word there? Composite shapes. That just means that you put a number of different shapes together to form one. Now, they say first draw a sketch to show how you have divided up each shape. I don't know if you guys read that and did that, but I'll just show you on the picture now. Give your answers to one decimal place, right? And this, I'm sorry if you did follow this instruction. For some reason, they keep saying this in the textbook, but in at Western, we just use touch, all right? The button on the calculator. We don't work with 3,142. This is a value of pi around and all, but we just use the actual value on the calculator. Okay, guys, now for this, you could do any number of shapes, right? That you could, well, there were multiple ways in which you could divide it up. Let me just see if I have a pencil here. And then I can show you there on the picture. Right there. Thank you. What's happening with Alright, so I can otherwise we could divide the shape up, right? So yours could be different from my own shape. We'll just see if we get the same answer. And then you can do that. And you can do that. Right? I would say that this is rectangle 1, that's rectangle 2, that's rectangle 3, that is rectangle 4. It doesn't have to number them like that, so that when I'm explaining, you can all follow. I'm numbering it. Yes, perfect. I don't even have to number them label. So guys, the area of this whole shape is going to be the area of rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4. I'm going to do it all in one line. Can we try to do it all in one line, please? Right? If you did it, when you did it as homework, we're going to write it out now. The area of the first one is very easy, right? 11.5 times 4. Yes? Let me write it out. Okay, so area. Bye-bye. In brackets, guys, for this one area calculation, we're going to do 11.5 times 4. Close brackets plus. That's my first one. If you broke it up into shapes that are different from this, it's fine. In your calculations will also be different. Now we must figure out, I think we can all see that this side of rectangle 2 is 4, right? Are we all fine with that? But now here, how am I going to work that out? Yes, Jaden? Okay, so it's okay, so the whole shape is the whole length, 11.5. Right, do we agree that this is 11.5, that will also be 11.5, right? Okay, and then? So I minus 4 from it. Okay, I'm just looking for that side there, guys. So the whole side is 11.5. That part is 4. So this part will be 11.5 minus 4, which is what? 7.5. Yes? But wouldn't it be 6.7 with that? These two are not, so that one is 6.7, but not this little one. You see that one is a bit higher than this one. Okay. All right, guys, that's the second one. Third one, this length again is 11.5. And this length they've given us, how nice, 6. All right, so that's the third one. Plus 11.5 times 6. Plus the last one, those dimensions were also given 4 times 6.7. Right? Now, all you have to do is in one calculation using your brackets, you're going to type this whole thing in. I'm just going to do it quickly and see what I get. One, and they set to one decimal place. 171.8. We got that answer for 1A. Okay, good. Any questions on that one? All right, let's look at B. So guys, they've already actually broken B up into shapes for us here. All that I also want to do is I want to draw a line there. Right? Is that fine? So this shape that we had here was a trapezium, but we haven't done trapezium yet, and you don't actually have to know the formula for the area of a trapezium. Okay, because any trapezium you can split up into a rectangle and triangles. All right. So what shape is this, guys? What do we think? This one here. It's a rectangle. Hey, it almost looks like a square, but if you look at the actual lengths here, you'll see that they're different. Okay, so this is a rectangle. This is also a rectangle, right? Do we agree? So that's 6 and that's 4,8. Now we need to figure out, we have two right angle triangles here, all right? I need to find the base of each of them. Do we agree that the perpendicular height is what? 4,8 of both of them, right? That's the actual height of the triangle. Okay, so the perpendicular height. So guys, I need to work out what that is and what that is. How do you think I'm going to do that? Distance. 16.5 minus 6. Yes, good. That's going to give me both of those. And then divide by. Okay. But in this question, actually, they didn't really give us all the information that I feel they should have. I feel they should have told us that these two are equal. Right? Which they didn't. Unless I'm missing something. Yeah? Cool? I did the right. Yeah, I did. Okay, I don't know if I'm missing anything else there, if they did tell us that they're equal, but we would have to assume that they are in order to do this question. Yeah. If you wanted to, guys, can we just quickly imagine, let's use our imagination. Let's move out that top triangle. Move it up in your mind. Are you doing it? And then the bottom one, move that one up. Put them together. What would you get? A triangle that looks like this, hey? If you take that part out, that will be that top triangle. And this part, and you put them together, then this distance, that base, will be 16.5 minus 6. You can actually do that, which is 10.5. Are you guys following what I'm saying? So instead of thinking of two separate triangles, we can actually form one triangle.